All right, so in example number 2, I threw a negative in on the original problem. It already has a negative on it. This problem is already reflected, correct? So this graph itself is already an upside down parabola. So as we go through these questions, we may see that change for different reasons. So again, when you're doing these problems, whatever the original problem is has to go in Y2. So to insert a negative, you just press second delete right in front of it and put the negative instead of retyping the whole thing. Now the first one, for the Y1, it says put 5 on the whole problem. So that means 5 times negative x squared. Now we know that's negative 5x squared, right? But let's say we didn't know that. Well, if you didn't know that, you could just simply type it in without fixing the math at all. And the calculator will do the math whether you fixed it or not. It don't care if it's simplified. So when we do that, we know that comes out to be negative 5x squared. So I'm looking for, from the original problem, what change is made. So when we look at the graph, and of course we know the original is the bowl, and we know that the skinny line is not, then did it do what you think was going to happen? What did the 5 do to it? Compressed. So that makes sense. It actually stretched it taller like the funhouse mirror, and it didn't reflect it because it already had a negative on it, right? Okie dokie. So that makes sense. I'll come over and answer in just a second. Now, let's look just really quickly at doing the 3x one, and then I'm going to let you try the other 4. 3x would have to be on the inside, right? Everybody agree? But there's a negative. Where does it go? Inside the parentheses or outside? Is it inside up there in the original problem? Yeah, it's not, is it? That's negative 1 times x squared. It's out here. So when you type that in the calculator, I could put the negative right there. Well, put the 3 here. And put the square on the outside. So you can just make adjustments to your problem, not have to retype the whole thing if you don't want to. So it's negative x squared, take out the x and put in 3x where the x was, so that made that the inside part, so that when we graph it, did the negative reflect it from what it was originally? No. The original problem was reflected. It's still reflected. But is it still compressing because of the 3? Yes. So the key is, as long as there's a negative in front of the problem, if you type it correctly, if the negative is in front, it's going to still stay reflected. And if you put numbers that are greater than 1, it's going to compress. And so this graph was already reflected that we started with, so it's still reflected, and it's compressed for both of these questions. So now I'd like you to try the next 4 and see what you get. So when you're putting these in, if it's inside this parentheses, that means you make the problem with a parentheses where the x was. And that way you know what's inside the parentheses came out of there. Okay? But if you're doing this one down here, the whole entire problem becomes the parentheses because you're wanting to do negative 9 over 4 times the whole thing, which changes the problem. Now it don't reflect anymore, right? But this one compressed because isn't 9/4? Isn't 9/4 bigger than 1? Is 2/5 bigger than 1? Then this one stretches. And because it already had a negative in the problem, it's still reflected though, right? The graph originally reflected, it's still reflecting, but now it's stretched my reflection. So, if I do negative 2 on the outside, then I do negative 2 times the original problem. I guess my reflection went away. And did it compress? 2's bigger than 1, so it compresses. And then down here, if I put the negative parentheses squared down, then I can plug in the negative 3x in there. Come on. That's going to square the negative out, but it's still out here, isn't it? So it still reflects. But what does the 3 do? Compresses. So sometimes when you put a negative in a certain place, it will do away with the reflecting and it won't open down anymore and it'll open up. It just depends on, are you multiplying it by a negative to get rid of it? Are you squaring the negative out? Was there a negative already there when you started? Makes a difference. The next thing I want to look at is what if we put some addition or subtraction into the question? So one of the things they want us to do is look at what happens if you put x plus k in the parentheses. You put some adding or subtracting inside the problem versus f of x plus k on the outside, which means you put it on the end of the question. That makes a big difference in what it does. And here I have 4 examples for us to do. And we're doing them with x squared, so go back to y2 and take off the negative. Because now we're going back to the plain x squared term. So since I am putting f of x is this x squared, that means I'm doing x squared plus 6. Does that make sense? Does everybody see how I did that? I am just adding it to the end of the question because it says take the original function and add 6 to it. Now that is different than this one over here. This one over here says take the x out and put in x minus 3. Does everybody see the difference between inside and outside? If you're putting it on the end of the question, you're going to put it on the end of the function. But if you're putting it inside of the parentheses, that means you're going to put it in place of x inside the problem, which means you have to take the x out and replace that whole parentheses inside there with x minus 3. So what would I do here? Put it on the end or put it on the inside? Put it on the end, so it'll be x squared minus 2. Where am I going to put it on this one? Inside. So I'm going to make my parentheses squared, and inside there I'm going to take out the x that is the original problem and put in x plus 4. So now that we have our 4 problems set up, I want you to type each one in the calculator and compare it to your bold one to see what happened and write down how it changed on your paper, and then we'll discuss them and maybe if we can come up with a rhyme or reason. And while you're waiting for others to finish, if you can think of a rule that makes it work, jot it on your paper so that we can come up with one to talk about out loud. Okay? So I'm going to pause the video while y'all do that. Alright, so when you look at addition and subtraction, it's not going to do the same thing that multiplying does. Okay? Multiplying by a negative, we found out, reflects. And multiplying by a number greater than 1 compresses and less than 1 stretches. But those are not the only things that can happen. Because if it was, I couldn't move across the room. I'd just be standing here all day going, okay. No. That would be kind of silly. I'd like to move across the room sometime. So, the key here is that if you have a graph, whoa. Okay, how did I do that? I don't know. But if you have a graph, like this graph, one thing you can do is multiply it like by half and make it wider, right? But I could also multiply it by negative 9/4 and it'd make it really skinny and reflect. That's just 2 of the things that could happen. So you're telling me that when you did part A and part B, that they did right the opposite of each other, and y'all said that was the up and down. That's positive 6. Well, let's think that through. See, when you take any number and you square it, that's your y value, right? And then when you add 6 to the y value just went up 6 more. Does that make sense? That this is up 6, and this one's left 2. Or not left 2, excuse me, down 2. Because I'm adding it after I've already done the other part of the problem. I have to square it first and then add that number. But over here, you do what's in the parentheses first. And what's in the parentheses is attached to x. So if I plug in any x, like 4, for example, and I go 4 minus 3, it's not on 4 anymore. It's over here on 1 now. Or if I put in 4 down here, and x plus 4, it was on 4, but now it's on 8. So the key here is, when you look at these problems, they slide around. So which way did these go? What did the x minus 3 do to the question? Move to the right? Is that what you said? This one, the second one moved to the left? All right, so this one went to the right 3, and this one went to the left 4. All right. So the key here is there any rhyme or reason to what it did? Well, let's see. If it's on the end, it did what it said it was going to do. Plus made it go up, and minus made it go down. Well, when it's minus, it went to the right. Does that make sense? Doesn't really, does it? But this goes back to what we discussed yesterday about vertex form. It does the opposite if it's in a grouping symbol, right? So when I make this the opposite to positive 3, then it makes sense that it went to the right. And because it's attached to x, it had to do an x direction. You see, anything inside of a grouping symbol always moves x. Anything outside of a grouping symbol always moves y. So it always does the opposite on the x part, and it always does the same thing with the number on the end. All right. I think I'm going to skip number 4, and I want to look at this one instead. So we're going to make this our number 4. Okay, the original problem here is a little bit longer. So here's your instructions. I want you to try this before we move on to the last thing we're going to do. And that is, your original problem this time is 2x squared minus 5. So this problem is already bigger than x squared, isn't it? But it still could stretch or compress more than it already is. It still could reflect from what it is, and it still could move up, down, left, or right. So what I want you to do is, in looking at each one of these questions, I want you to be careful about how you type it on the calculator. That's really important. Because if it's inside the parentheses, it stays inside the parentheses and goes in the place where the x is. And if it's on the outside of the parentheses, it's done to the whole problem. Okay? I want you to try each one of these in your calculator. And don't simplify any of them. Just type them not simplified. And see if they do what you think they're going to do with up, down, left, right for slides because of adding and subtracting. Or if I'm multiplying or have a negative that I'm working with, does it reflect, compress, or stretch? Does everybody understand the direction? All right, I'm going to let y'all try that one, then we're going to go over it. All right, so when you graph a problem, you can see it's very difficult to figure out where do I put the parentheses. Does it go on the outside? Does it go on the inside with what I have here? So let me show you a couple of rules here. When you have f of x with plus or minus inside, it's going to go left or right. And you just look at it and think the opposite of what you have. But when it has f of x and the plus or minus is on the outside, plus is going to go up and minus is going to go down. When your negative is on the outside, it's going to reflect. When your negative is on the inside, that's questionable. You'll have to look at the problem you have and decide if the negative goes away. If the multiplied number is greater than 1, it's going to compress. And if it's less than 1, it's going to stretch. And you don't need a calculator to figure these out. So, it's inside. So inside plus or minus, it does the opposite. The opposite of this is because x minus 3 equals 0 makes it 3. 3 goes to the right. This is on the outside. It says subtract. Subtract on the outside says it goes down 1. Here is negative on the outside. Negative on the outside says, whoop, drew it to the wrong spot. Negative to the outside, come on. Negative on the outside says reflect. The 3 itself does something different. 3 by itself is greater than 1. Since 3 is greater than 1, it compresses. This one, 5, 6, without the negative on it, is less than 1. So it stretches. The negative itself is the only thing you have to make sure you think about. So if I put this inside the square, that negative will square off, so it does not reflect. That's how you need to be able to do it, not using your calculator. The calculator just helps you to discover the rules, because these are the rules for everything. Squared, square root, absolute value, everything has these rules, not just quadratics. Now you can finish your assignment, but you'll have to re-download it because I changed the assignment for those of you who already have it open in Canvas.